Most times, of course, students find it difficult to analyze questions under AC, but this question will make it very simple, all right, especially when it has to do with a circuit of a capacitor and a resistor, all right. It will give you a hint on how to solve other problems. All right, this question says an alternating source is connected in series to a capacitor of capacitive reactance of 10 raised to power 3 square root of 3 ohms and a resistor of resistance 10 raised to power 3 ohms. Find the impedance. Find the what? The impedance. This is a circuit. This is an RC circuit. That is a circuit that connects the resistor and the capacitor. All right. This is the capacitor. Right. The reactance of capacitor. What it means is the opposition offered by a capacitor. That is the value. Then this one is the opposition offered by the resistor. In simple terms, the diagram of this question can be, of course, we have, this is a capacitor of capacitive reactance 10 raised to power 3 square root 3, right, ohms. This is XC. Then this one is our R. R in this case is what? 10 raised to power 3 ohms. Then it's connected to an alternating source. This is just the simple diagram of this question. So all we need to find here, according to this question, we are expected to find the total opposition offered to the flow of current by these two components. Okay? The total opposition. That is what we call the impedance. So it is very simple. Impedance Z is equal to the square root of XC squared plus R squared. All right, that is the impedance. This Z here is the total opposition. That is what we call the impedance. Then this XC is what we call the reactance of the capacitor. That is the opposition offered to the flow of current by the capacitor. Then this R is the resistance of the resistor. That is the opposition offered to the flow of current by this component called the resistor. So for us to be able to find the total opposition, which is the impedance, we just substitute these values we have from this diagram, substitute it in this formula, and then we solve. Square root of 10 raised to power 3 square root 3 all raised to power 2, then plus R in this case is 10 raised to power 3, 10 raised to power 3 all raised to power 2. I believe that you know how we got this. This particular value here, R, is 10 raised to power 3. That's why we substituted it here. Alright, so going further, we now have that our Z is equal to square root of course, this belongs to, this square here belongs to this 10 raised to power 3, and it belongs to 10 raised to power, it belongs to 10 raised to power 3, and it also belongs to square root of 3. That means we are going to have 10 raised to power 3 raised to power 2, then multiplied by square root of 3 raised to power 2. Then before we now have plus 10 raised to power. Of course, this 3 here, we multiply the 2 outside the bracket, and then we're going to have 3 times 2 here is 10 is 6. Alright? So going further, we now have that our impedance Z is equal to square root of this 3, we multiply this 2 here, and then we have 10 raised to power 6. 10 raised to power 6, then multiplied by, of course, this square root of 3 raised to power 2. This square here will cancel the square root, and what we have left is 3. So we have 3 here. Alright? Then we now have what? Plus 10 raised to power 6. Is that okay? Okay, then inside this square root, all we have is, of course, we factorize this 10 raised to power 6 multiplied by 3 plus 10 raised to power 6. We factorize it, and it will give us 10. Okay, what do we have in common here and here? It is 10 raised to power 6. Okay, then if it goes here, we have 3 plus 1. We have 3 plus 1, close the bracket. Alright, so what we have left is that Z is equal to the square root of course, 3 plus 1 is 4. Then we have 10 raised to power 6, then multiply by 4. Okay, 10 raised to power 6 is what? 1 million. 1 million times 4 is what? 4 million. So what we have left is square root of 4 million. Okay, yeah, square root of 4 million. And then square root of 4 million is what? 2000. Our Z is equal to 2000 ohms. 2000 ohms. You can see how big the value is. The total opposition offered when you have a capacitor of capacitive reactance, this value, and a resistor of resistive reactance. Of course, what we call this particular one is resistance of the resistor. So it is 10 raised to power 3, that is 1000. So these are two big values, and then we are expected to get the net impedance or the net or the total opposition to be also great, that is 2000 ohms. You see, very simple way to solve it. Thank you very much, and God bless you.